right, here we're looking at our notes for this next section, and we always start with our learning targets, and you can see right here we can graph logarithmic and exponential functions using transformations. So really what we're going to be doing today is starting with those parent functions for both of these types of functions, and then using our transformations. So the sheets that you will need are these ones. We're going to make little flip booklets again to show our different graphs, okay? And I put them both on the same page, but you're going to want to cut these out and put them in this order. We've used these before to show these same transformations, right? So that's why we're using these, just so we can get an idea. So on the very front page, you're going to do your parent function, and our parent functions for today are, we're just looking at the exponential function of 2 to the x and then log of x, okay? So then you'll see we're going to have a horizontal translation and what that means and where it goes. So if you want to kind of make up your own equations here, you sure can, but make sure that you use Desmos to help you understand what exactly is happening. So again, our horizontal translation is the shifting back and forth, is again part of that exponent, and it always goes in kind of the parentheses with our x. So you'll see in both of these, okay, it's our x minus h. So we always are going to have that x minus h, and that h is our translation from our parent function to our new function. Okay, so then our next one is a vertical translation. So vertical is just up and down. So vertical means it's not in the parentheses and it's not with my variable. It's kind of a little bit further away from my variable. So here you see I've got a 2 to the x and then minus 2 out here. So when we're dealing with logs, you have to be very careful. So these two things, right, log of x minus 2 and then log of x minus 2 look very much the same, but you'll notice that the parentheses really matter. So make sure you're being very careful and specific with these. And then we look at reflections, and we have two different ways that things can be reflected, right? They can be reflected over the x-axis, and they can also be reflected over the y-axis. And those look slightly different. So here you'll see where we have both of those, okay, and kind of what they do and what they look like. And then we've got our horizontal stretches and shrinks. So what I did here too is, because since we're going horizontally, it's kind of backwards. So if I have that positive value that's greater than 1, it's really a horizontal shrink, right? Because from horizontally I'm like smushing it. So I'm giving myself those couple of words just to remind myself. And then we'll look at this last one, which is our vertical stretch and shrink. For both of them, I have a stretch and a shrink. Okay, so you'll see the stretch and the shrink. So one thing I want you to notice is, especially on this exponential one, that where my y-intercept is. So when I have that horizontal stretch or shrink, so that thing that's up in the exponent, my y-intercept stays the same. Whereas if I have that vertical stretch or shrink, that changes where my y-intercept is. And hopefully you'll notice from my parent function it went up to 3 with that vertical stretch, wherein it went down to 1/3 with that vertical shrink. So that actually matters. And just look at kind of where different values change on our graph, okay? So this is where we're absolutely going to be using Desmos.